Hello, good morning, everyone. Last time we started to talk about 1.6, solving other types of equation. Uh, I start by giving a polynomial equation for degree higher than 4 degree more than 2, like x to the power 5 or x to the power 6, for example. And I gave example for how we can solve equation of power for polynomial raised to the power more than 2. And also I give example for a fractional expression. Then in the end, just we solve like an example for fraction expression. We left only one example is for this section is example here. Solve the equation. This equation has like radical. So the equation is like radical of the equation. The equation is here. Is x equal 1 minus the square root of uh, 7 minus x. So any idea how we can start solving something like this if we have radical like this?
To get rid of the radical, you would square both sides. No, first you have to subtract 1 to get the radical by itself, and then square both sides to get rid of the
Exactly.
radical.
Yes, exactly. So the first things when you see something like that, I prefer to move everything, like to move the radical to one side and everything else to the other side. So here I have x equal 1 minus the radical square root of 7 minus x. So I prefer to make the radical here, the square root, only in one side, and everything else, I mean x and the 1 and the other side. So to make this thing, you have to subtract 1 from both sides, minus 1, minus 1. Now, when you subtract the 1 from the right side, they will cancel here, cancel out, because 1 minus 1 is 0. And here in the left side here, x minus 1 equal minus the square root of 7 minus x. Now, what is the second step?
I think
Yes, go ahead. Sure. Can't hear you.
can you hear me?
Yes, sure. Yes. So what is the next step?
You would divide -1 on both sides to get rid of the negative.
What about if we square both sides with the negative?
Um,
Because -1 square is 1, right?
just yeah.
Okay, so I prefer, instead of dividing both sides by negative, to square both sides with the negative, like this. You can divide it, will be fine, but also if you square everything with the -1, will be work fine. So now the square root of the minus raised to the power 2, they give me +1, and the radical raised to the power 2, they will cancel out, right? So here I can get 7 minus x on this side, and at this side I will get x squared minus 2 times the first term times the second term 1 plus the second term square, the one here square. Again, this is equal the first term here square minus 2 times x times 1 minus plus the second term square. Now I get x square minus 2x, because 2 times x times 1 is 2x, plus 1 equal 7 minus x. Again, how I get this one, x square minus 2 times x times 1 plus 1 square? I can do it like multiplying, because x minus 1 square, this is equal x minus 1 times x minus 1. Then I can distribute everything inside the parentheses. I mean, for that, I can multiply the x with the parentheses and the 1 with the parentheses. So I can get here down, this is equal x times x minus 1, x times this parentheses, minus 1 times this parentheses, x minus 1. Now again, distribute the x inside this parentheses and distribute the minus 1 inside the parentheses again. So I can said like the x times the x and the x times the minus 1, the minus 1 times the x and the minus 1 times the minus 1 times the minus 1. So here I can get x times x is x square, x times minus 1 is minus x, minus 1 times x is minus x, and minus 1 times minus 1, they give me plus 1. Now simplify these things. Here again, get x squared minus 2x plus 1, because minus x, we can combine this variable together. Here I have 1 in front of x. I mean, I have minus 1 in front of x. Also here I have minus 1 in front of x. So minus 1 is minus 2, x plus 1. Or we can solve it by the formula faster than this. I can say here x minus 1 square, this here, x minus 1, so this one here, x minus 1 square, this is equal, the first term is x square minus 2 times the first term times the second term. First term is x, second term is the 1 without the sign, we don't have the sign, plus the second term square minus 1 square, and this is equal x square minus 2 times x times 1 is 2x and plus 1 square, and this is what I get here. Now go back to the example. What I should do now, how we can solve something like this, x squared minus 2x plus 1 equals 7 minus x. What I should do here?
I have a question.
Yes, go ahead.
When you square rooted, when you squared the square root of negative 7 minus x, why did you why did you remove the negative? Like, isn't it supposed to be now negative 7 minus x, and then you remove the square root?
Here you ask about this one here.
Why did you remove the negative?
Okay.
It's because when you multiply it 2 times, it becomes a positive 1. So it's same thing. It's like invisible.
Exactly. So all I can say here, the negative raised to the power raised to the power 2 and the radical raised to the power 2. I distribute the 2 exponent here inside the parentheses.
Oh, okay.
I distribute the 2, the radical, inside the parentheses. Here minus, this is mean minus 1. The minus means here it's minus 1. So I distribute the 2, the exponent 2 above of the minus, because -1 square equal -1 times -1, and -1 times -1 is 1 positive. So this is like +1. And distribute the 2 to the radical. I will cancel the radical with exponent. I will get inside the radical is 7 minus x. Make sense? Clear?
Yeah, it's clear.
Okay. So now what's the next step here? What I should to do here? Now I get x squared minus 7 minus 2x plus 1 equals 7 minus x. What is my next step?
You subtract you add 2x to the both
Subtract. Yes.
and you subtract 1 from both
No,
sides.
you would rather take the smaller part to the bigger side, then it's less work.
Yes, exactly. Like take this one here, easier to this side. I mean, take this side, this to this side is more easier because we have 2 terms here, rather than taking all these terms to this side.
You wouldn't be wrong if you do that, but it's just extra steps that you don't have to take.
No, will not be wrong. No, they will not be wrong. Yeah, this is correct. Will not be wrong. But I prefer to move this one to this side. Is easier. So to move this one to this side, I prefer what you have to do. Eric asked question, is this another equation? No, it's not another equation. This is explanation for what I did here for x minus 1 everything squared. Just I explain how I get here x squared minus, how I get x minus 1 everything squared as x squared minus 2x times 1 plus 1 squared. Now here in this equation here in this step, I mean, I have to move all this to this side because I need to make one side 0 and the other one is the equation. So to move this one to other side, I have to subtract 7 and I will add x in both sides. Subtract 7, they will give me 0 for the 7, and when I add x, I will get 0 for this variable. And the same things in this side, I have to subtract 7 and I have to add x for both sides. Now my new equation, so here my new step is x squared minus 2x plus 1 minus 7 plus x minus 7 plus x equal 0, because the other side they will cancel out here. So here is 0. Now I need to simplify this more and more. So to simplify this, I have the x goes down, x squared minus 2x minus 7 minus 2x plus x is
Minus x.
9, minus 2 plus 1 is
Negative x.
a negative, yes, is negative 1. So I get negative x, and plus 1 minus 7 is
Minus 6.
minus 6. Minus 6 equals 0. So this is my equation I get from this one. Now, how, like, this is like, which kind of equation is that? Is it a linear equation?
It's a second degree, so it's a quadratic.
A quadratic equation, yes. Because it's a second degree, so it's a quadratic equation. So last time we learned how to solve a quadratic equation by 3 steps. First one is by factoring. Second way is by using the quadratic formula. And the third way by completing the square. But the best way here to use, I'm going to use the factoring. How we can factor this quadratic equation? What is the factor for this one?
3, -3 and 2. So
Looking for two numbers, the multiplication is -6, the sum is -1. So -3 and 2, you said, right?
yes,
So -3 times 2 is -6, and -3 plus 2 is -1. This is correct. So here the factor is x minus 3 times x plus 2 equals 0. Now I'm going to use the zero product property. The zero product property, like we used it last time, is talking about if I have a, b equals 0, if and only if this implies a equals 0 or b equals 0. So I'm going to use this property to solve this equation. Again, so this is my a. So all this parentheses is my a, and also all this parentheses is my b. So applying this property, a equals 0 or b equals 0. I mean, like x minus 3 equals 0, or the second one is x plus 2 equal 0. Now what I should to do to solve for x?
Add 3 to the both sides.
Exactly, add 3 to both sides. And what I should to do here?
Subtract 2 to the both sides.
Yes, subtract 2 to the both side. Here, cancel out. I get here x equal positive 3 or x equal -2. Now, after I finish everything, I should to check, is x equal 3 and, or I mean, x equal -2 are a solution for this equation. To check that, I have to plug the 3 inside the equation and check if the both sides they give me 3. And then I have to move to the -2 and plug it again inside the equation to check if the both sides they give me the same answer, I mean, or equal. So my question, my example is x equal 1 minus square root of 7 minus x. This is my equation. Now I have to plug this number x equal 3 inside this equation. What I'm gonna get when I plug it? Any student wanna help?
what's the question?
When I plug x equal 3 inside this equation, or in my equation, my question equation, this is one. X equal 1 minus the square root of 7 minus x. I just write it here again. When I plug this one inside this one, what I'm going to get?
Can I say?
Two solutions?
Yeah. No, I need to check this one is a solution for this equation. I have to plug this one inside the equation.
Oh, so the square root of 4 is 2. 1 minus 2 is minus 1.
I'm going to do it step by step. So x equal 3, I plug the 3 inside the equation. I will get 3 equal 1 minus square root of what? 7 minus what?
7 minus 3.
3, exactly. Now I have to check this side equal to this side. So the 3 goes down, equal 1 minus, what is the square root of 7 minus 3?
4.
Square root of 4, this is correct. Now this goes down again, equal 1 minus, what's the square root of 4?
2.
It's 2. Now I get 3 equal 1 minus 2 is?
-1. It's a false statement.
False. Is the 3 equal to -1?
No.
Is the 3? No, this is not correct. Here is not equal.
But
So
I have a question.
yes, go ahead.
Like the square root of 4 plus or minus 4?
Okay. This is plus or minus for like solving equation. When I told you x squared equal 4. Now you take the radical for both sides. You said x equals square root of 4. And then you have to give me the answer, x equal positive or negative 2. But that's why they give me the two answer, positive and negative. But if I told you, what's the square root of 4 without equation, without solving equation, what do you give me the answer?
2.
Only positive 2. What's the square root of 9?
3.
Only positive 3. But when I told you solve the equation, you should to give me positive, negative.
Oh, okay.
So here we doing numbers, not equation. So the answer for the square root of 4 is only positive 2. But we have already negative in front. So negative times positive, they give me negative, and the square root of 4 is 2. So I get negative 2.
Can we check the other one that we got? X equals -2.
Can you, what's your question?
No, I said like, can we check the other solution that we
Yes,
got?
yes, exactly. So this is, so here I can say, so x equal 3 is not a solution. So x equal 3 is not solution, is not
So on the
solution.
after you get these two solutions, you would have to check both of them in the end.
Exactly. You have to check. Why? Because here they give me the question x equal 3 and x equal -2. But actually x equal 3 is not a solution after I plug inside the equation. Look, I get 3 equal -1, and this is not correct. So 3 actually not equal to -1. So x equal 3 is not a solution. Now I'm going to check for x equal -2. Yeah, I'm going to write it as this. So x equal 3 is not solution. Not solution. Now I'm going to check for the other one. For x equal -2. Who will do it? Who will do the second one? X equal -2. Mohsen, he said x equal -2 is a solution. How you know? How did you plug
Yeah,
inside the yes?
so we just like the other one, we substitute it, and then we get inside the radical, which is 9, and we take it out from the radical. It gives me 3, and with the negative in front, so 1 minus 3 gives me -2.
Okay, this is correct. So she plugged this equation again inside in this solution inside the equation. So here the x is -2 equal 1 minus the square root of 7 minus -2, like this. And now this goes down here, -2 equal 1 minus square root of 7 minus -2 is 9. Now I get again -2 equal 1 minus the answer of the square root of 9 is 3. So again -2 equal 1 minus 3 is -2. So this is correct, but this is not correct here. So -2 equal -2. So this is a solution for this. This is the only solution. So x equal -2 is the only solution for this equation, for the equation. Here. For the equation. So x equal -2 is the only solution for this equation. Why? Because I get the answer -2 equal -2. Any question for this example? Makes sense? But here is not a solution. Okay. Now, this is the only example here we left in this section. So this section is finished. We take all the cases for other types of equation. Equation of polynomial has degree more than 2, like x to the power 5, for example. And then I give the other one, the other example for a fraction expression. And the other one, the last one is the radical. When the question asks solve the equation and the equation has radical. Yeah, Eric, what's your question? Eric has a question. What's your question? In the other slide, why did you wrote x minus 1 square equal x minus 1 times x1? Okay, in this slide, I wrote this one to explain what is the meaning of x minus 1 square. X minus 1 square is equal the same as x times minus 1 times x minus 1. Like when I said 5 square, what is 5 square? 5 square is mean here. 5 square is equal 5 times 5. So the same thing here, I just explained what I did. X minus 1 square is x minus 1 times x minus 1. Then I distribute everything inside the parentheses until I get x square minus 2x plus 1. So x minus 1 square is the same as x square minus 2x plus 1. And this is what I did here. X minus 1 square, this is equal x square minus 2 times x, 2x plus 1. Okay, Eric? I wrote this one to explain what is the meaning of x minus 1 square and to get this answer. Here I get another question. We do have 1.7 solving inequality for chapter 1. 1.7? No, we don't have to. Yes, we will do it 1.7. 1.7 inequalities. Yes, we're going to do the inequality. But we're going to do it later, not today. Now we're going to go back to 1.1 coordinate plane. So I start for B8, then I move to 1.4 quadratic equation, then I move to 1.6 other types of equation. So actually I finish all types of equation. Now I'm going to go back to 1.1 coordinate plane. So we finish 1.6 here. Now let's go to 1.1 coordinate the coordinate plane. The plane. So now let's go back to the chapter 1.2. I mean, like to the previous section 1.1, the coordinate plane. First of all, we have to know what does that mean, coordinate plane. Any idea for coordinate plane? What does that mean? Have you heard about this definition before?
It's a plane consists of 4 quadrants.
What is that?
Go ahead. Somebody was saying something. It's a coordinate plane with 4 coordinates,
For,
four quadrants.
yes, it's a 4 quadrants. This is correct. Who will said? Who has another? Yeah, this is correct, Shop. Who has another idea or definition or any idea about coordinate plane?
It has a positive and a negative side.
Yes, they have also positive side, negative side. This is correct too. And we have also order pairs also, if you have, and also we have
origin.
also we have origin, and we have x-axis and y-axis, and we have order pair like the origin 0, 0. So I can define the coordinate plane as points is a points in a plane can be identified with order pair, with ordered pairs of numbers to form the coordinate plane. This is like a general definition, just to know what is the meaning of coordinate plane. Now, if we have like in the coordinate plane, we have a perpendicular real line. This perpendicular real line that intersect at point is O or 0 on each line. So if I have like the coordinate plane, it's like 2 perpendicular line. This is the first line, and this is the second line. And both of the lines are intersect. Both of them are perpendicular to each other. I mean to each other, and they are intersect in this point. This point is the origin. So now, so I can here said perpendicular real lines that intersect at O, I mean the origin on each line. So both of the lines intersect at a point. This point is the origin here. This is the point where the both of the line are intersect. This point. This is the O. I mean for the O here, O equal origin. The origin is like order pair. The order pair is 0, 0. So this point is my origin. Now, also I should to know. So here I will. Also I have to know the two lines divide the plane into fourth quadrant. This is the first quadrant. This is the first quadrant denoted by I. This is the second one, double I. This is the third one here. And also this is the fourth one here, denoted by I here like this. So this is the first quadrant. This is the second one. And this is the third. Here's the third. And this is the fourth one. Fourth quadrant. We should know also any point in the coordinate plane can be defined by order pair, like parentheses has the x coordinate and the y coordinate. Just the last here, the last thing here, any point in the coordinate or the Cartesian plane can be defined by order pair x comma y, a comma b. The x here means the x, this x means the x coordinate. This is my x coordinate. And this is my b. This is the b here is my y coordinate. Okay. Any question for this 3 points here, the red and the green and the blue one, or here in the graph? Makes sense what I said here about Cartesian plane and okay. So now let me give the definition, the formula of the distance and the midpoint formula for any 2 points in the Cartesian plane. So here the distance and the midpoint formulas. So suppose I have 2 points in the Cartesian plane like this. This is my Cartesian plane. This is here is the x-axis. This one, the x-axis. Here's x-axis. And this is my y-axis. And we have 2 points. The first point is here called A. And this point has x1 comma y1. And the point here, the second one is B, has x2 comma y2. Okay, so we need the distance between these 2 points is look like this. The distance between this point is look like this. Move it, make it more smaller. So I can define the distance between A comma B equal, it's the square root of x1 minus x2, or I can say x2 minus x1 square plus y2 minus y1 square, y2 minus y1, everything square. This is the definition of the square. Get more here better. Again, it's x2, this point, minus x1 square plus y2 minus y1, everything square. So I'm looking for the order pair for the first point and the order pair for the second point. I subtract the x coordinate from each of the point and I square it. Then I have to add it to the difference between this, the y point, the y coordinate point between the two order pairs, and I have to square them. In the end, I have to take the square root for everything. And also the midpoint. The midpoint I can define as the point in the middle. So this is the point here in the middle called M capital of x comma y, the midpoint between these 2 points. And the green one is the distance denoted by d between comma A comma B. And this pink color is the midpoint. So the midpoint M formula x comma y equal is, we have to open parentheses like this, and in the first x coordinate is x1 plus x2 over 2, and here I have y1 plus y2 over 2. This is the first coordinate, and this is the second coordinate. This is the x coordinate, this is the y coordinate. Any question for this two formula? This is the midpoint, this is the distance. Okay, I'm going to give example how to use this formula. So my example now, I prefer to do the example in the back because it needs more space. So the example number 1, plot the point A capital is -4 comma -3, and the second point, and B is open parentheses 3 and 2, 3 comma 2. This is the first step here. This is the first example. The second example, find the distance between A and B. Third example, find the midpoint M capital comma x parentheses x comma y. Who will do the first one? Where is this point 7 -4 and -3 located in the Cartesian plane? This is my Cartesian plane.
On the third quadrant.
In the third quadrant. Okay, we'll see now. So this is my y-axis, and this is my x-axis. So the first point is -4 and -3. So the x coordinate is -4, the y coordinate is -3. So this is my -4 in the x-axis. So here I have 1, -1, -2, -3, and this is my -4. And my y coordinate is -3. So I have 1, -1, -2, and minus 3. So actually the point will be around, like if you go down like this, and then where the cross between the 3 and 4 is the point, is the order pair of minus 4 comma minus 3. So the point will be around here. This is the point. Minus 4 goes down as a point, and minus 3 is here. Minus 4 and minus 3. Now, for the second one, find the distance between, for the second point. Second point is 3 positive and 2. In which quadrant this point located? 3 and 2. Which quadrant located the 3 and 2? The first one, this is correct.
Fourth one.
And what?
The fourth.
The fourth, but here we have the third. Some students, they said the third, some students, they said the fourth. First of all, yes, go ahead.
Oh, me?
Yes.
Oh, I think it's the fourth, because like when you put wait, 3 and 2, like the 3 falls into like where the -3 is right now.
But here we have positive, both of them positive. The both of the coordinate, the x coordinate and the y coordinate is positive. So the positive will be here and this side, and also the positive of the y coordinate is in the up. You see? So the point will be like in this.
I think that, yeah, both of them fall into the same quadrant.
Exactly. Exactly. Both of them positive. So here I have 3. So the 3 will be like around here, 1, 2, and 3. This is the third. This is the 3 is the x coordinate. So this is my 3 here. And I have the y coordinate is 2. So here's 1, here's 2. Like I said before, the intersect between the 2, intersect between the 3 and the 2 will be around like in this point. This here. Is here. Again, this is 2. And we follow this point. And here we'll follow this point. So again, the point look like this. So the point will be in the first order quadrant. So at this point, I have to name this point. This is my A, such that is -4 comma -3. And also this is my B, is 3 comma 4. Now, for the second part for this question, who will do the second part?
3 and 2, you put 3 and 4 instead of 3 and 2.
Exactly. So first, here they ask for the distance for the second part. Oh, here for 4 and 2, exactly. Here I have to, because here is 2, so this is 4 and 2 is not 4 and this is here 4 and 2. This is here's for 3 and 2. So for the second one, they ask for the distance between the point A and B. What is the formula for the distance between A and B? So suppose this is my x1. Which one is your x? If I want to start from this point, so I will keep, say, this x1, and this is y1, and this is my x2, comma my y2. Now, what is the formula? Distance formula between A and B.
So you have to put the square root sign
Okay,
and then x2 minus x1 in parentheses raised to the power 2.
exactly. So x1 minus x2
X2
or
minus,
x2 minus x1.
yeah.
Okay, doesn't matter. You should start from one of them. Yes, doesn't matter. Why? Because the square change the minus to positive. Doesn't matter which one you start, x1 minus x2 or x2 minus x1. Both of them correct. So here you start x2 minus x1 square plus y2 minus y1 square. But if you want to do it x1 minus x2 square plus y1 minus y2 square, both of them correct because the square, they change the negative to positive. And if they are positive already, they will stay positive. So they will not matter which one is the first. Now, if I suppose I suppose this is my x2, this is my y2, and the same things here. This is my x1, this is my my y1. So just plug inside the equation. So this is equal square root of x2 is 3 minus x1 is minus 4. So minus times minus, they will be positive 4 plus y2 is 2 minus y1 is negative 3. So again, negative times negative will be positive here 3. And we don't have to forget square. And also we don't have to forget the radical or square root. Okay, what is 3 plus 4 square?
49.
Here I get a question. Johanna said, why is not not a minus 3? Who will answer, Johanna?
Wait,
Who will
what?
answer? Johanna asked question in the chat box. Why is not a minus 3 here? Why we brought it positive?
It's because the minus, two minuses makes it positive.
Exactly, because the question, the formula has minus, and the point is minus 3. So minus times minus, they will change to more positive. So we change the sign from negative to positive, and y1 and positive, and we put the 3. Now 3 plus 4 is 7. Square of 40, square of 7 is 49, like Eric said. This is correct. This is 49 plus 2 plus 5 is 5, and the square root of 5 is, what is the square root of 5? It's
Square root
25.
of 5.
Correct. Now you take the square root of you simplify everything here. So here I get
74. So square root of 74.
Exactly, the square root
And-
of 70.
And to find the midpoint, think of it, you don't even have to use the formula. Just simply divide square root of 74 and you get the halfway point of that line. Right?
But actually the midpoint is a point, is not a distance. If
And-
the question asks what is the distance in the middle, your answer is correct. We divide this by 2. But if the question asks what is the midpoint, you have to find the order pair, the x coordinate and the y coordinate. Understand?
Yes.
If the question is what is the distance, the half distance between A and B, like you said, we divided by 2. But if the question what is the midpoint, you have to find the x, the order pair, the x coordinate and the y coordinate by the formula. Okay.
Isn't that 25. And why didn't you square the 3 and 4?
3 and 4. 3 plus 4 is 7, and the square root of 7 is
Oh, okay. So PEMDAS. We have to do the
49.
parenthesis first. Okay.
Yes, and here we do the same things. 2 plus 3 is 5. Square root of 5 is 25. And the sum of 49 plus 25 is 74. Now, what is the midpoint? The midpoint is a point in the middle, like around here. This is my midpoint. Capital X, comma Y. What is the formula?
X1 plus X2 divided by 2,
Exactly. X1 plus X2 divided by 2.
comma, Y1 plus Y2 divided by 2.
Exactly. Y1 plus Y2 divided by 2. It's an order pair. So here divide, here again divide. Now just plug everything inside this formula. So I will get this is equal. This equal here. X1 is minus 4. Minus 4 plus 3 is, what is my 4?
Negative 4 plus 3, which is
Negative
yeah,
4
right,
plus negative 1, right?
yes.
So negative 4 plus 3 is over 2. This is negative 1 over 2.
And then comma, negative 3 plus 2 divided by 2.
Negative 3 plus 2 divided by 2. They give me also a negative 1 over 2. Negative 1 half. So my midpoint is negative 1 half, negative 1 half. The x coordinate is negative 1 half, and the y coordinate is negative 1 half. Any question for this example? Makes sense what I did here? It's simple and direct. It's not hard. First of all, the question asks about the plot the point -4, -3. So you go to the x-axis, you choose the -4. This is my -4. You go to the y-axis, you pick the -3. Then you draw like a line like this, and the line for -3, and the intersect between these two lines is this point. So this is my first point. The same things for the second point, B parentheses, or the order pair is 3 and 2. The same idea. You go to the x-axis, you go to the 3 positive, you go to the y-axis, you go to the positive 2. The intersect again between the 3 and the line, the 2. And for the second one, they ask find the distance between A and B. It's a direct formula from before, from this slide. The distance between any point is the square root of the difference between the x coordinate square plus the y coordinate square. So you go back to the example here, you choose your x1 and y1. Also, you choose your x2 and y2. Then you plug inside the formula direct. So my x2 is here, for example, my x2 is 2. My x2 is x2 is 3, minus x1 is -4, and like we said, minus they change to positive 4. Same things for the other side here. Y2 is 2, minus y1 is minus, they will change to positive 3. And we square both of the answer here, both for the parentheses. So the first one I get 49, the second one I get 25, and I add both of the numbers, I get the square root of 74. This is the distance between this point A and the point B. Now for the midpoint, it's by using the previous formula. is the sum between the x coordinate over 2 and the y coordinate comma y coordinate over 2. So x1 and plus x2 is minus 4 x1 plus x2. So x1 is minus 4, x2 is 3. So minus 4 plus 3 over 2, and they will give me 1 minus 1/2. The same things for the y coordinate. Y1 is minus 3 and y2 is 2. So minus 3 plus 2, they give me minus 1 over 2. The same, the x coordinate and the y coordinate, both of them, they are the same. This is for the midpoint. This is the only thing we have to know, we should to know in this section. The formula for the distance, and also we should to know the midpoint formula and how we can plug it inside the equation. I mean, like how we can use both of the formula in the example. Now, the new section is 1.2. So 1.2, the graph of an equation. The graph of an equation. So we have to know here in this section how we can graph for the equation, for an equation. But first of all, we have to know how to, like, we're going to use, like here in this section, we're going to graph by using the plotting point and making tables. Okay. So first of all, we have to know what is the definition of a graph. Any idea about a graph or definition of a graph or anything about a graph? What is the meaning of graphs?
A graph is a visual for an increment, or I don't know, like something that shows an increase or decrease of something.
Yeah,
of a
something of this.
population.
What
Like of a
about points?
population.
Why do not connect it with points? Like points, we connecting to each other.
All right, like as
Right?
like an independent, like as the x increase, the y either increases or decreases depending on.
This is correct, but we go like a little bit far. Like, why you do not start by talking about points? Points that if we connect these points, we get like curve or something like that. Then the curve, some of the curve, this is increased curve, or some of them decreased curve. Like, I mean, like start from the beginning of the graph. But your answer is correct. Actually, is correct. Here I can define the graph as plotting many points as we can, then connect them by smooth curve. Like points, many points. This point, we put it in the x, like the Cartesian plane. Then we connect this point by smooth curve. This smooth curve, they give me like the graph of the function or of the equation. So I will start by giving some examples. So example 1, sketch of equation 2x minus y equal 3.
How
we can- So how we can sketch this equation? What we should do first? How we can graph this equation? Any idea how we can graph equation like this?
Yes, I can.
So,
So-
but yes, what Seth, he said make a table. This is correct. But in the beginning, we should to fix this equation, right? I mean, like we should to make this equation, we have to solve it for y. Like an equation, if you want to solve it, I prefer to solve it for y. I mean, like you have to make the equation like we learned before.
In the form of y equals mx plus b.
Exactly like this, y equals something in the formal equation. How we can do that? What we should to do? We should to move this one to this side. How we can move this one to this side?
By adding y to both sides.
Exactly, this is correct. And also the 3 move to this side. How can I move the 3 to this side?
Subtracting 3 from both sides.
Subtract 3. Subtract 3 for both sides. And here I have to add y for both sides. So when I add y for both sides, this will be cancelled and I get 2x. And when I subtract 3 from both sides, I will get 2x minus 3 equal y. This is correct, Eric. Victoria, this is correct too. Subtract the 2x. Yeah, you can also, Victoria, subtract the 2x from both sides. And also after that, I should divide all sides by -1 because I need the formula y equal the positive of y. So now I can also rewrite this one as y equal 2x minus 3. So y equal 2x minus 3. Now, we should to graph this one by making what? A table. So we have to make a table, small table. Here is the table.
Start at 0, x equals 0 and y equals -3.
Yes,
right?
we're taking like random points. Taking random points 0, 1, 2. Okay, I will show you how we can do it here. So I need 0, 1, 2, 3, the x. Okay, that's good. And so in this table, I need the x coordinate. This is my x coordinate. This is my y coordinate. And here's the order pair. So this is my x. This is y equal to x minus 3. And this is the order pair x comma y. I'm going to use random points. I prefer to use the 0, the 1, the 2, the 3. Also, I want to use like negative, for example, -1. So for the first point, -1, when I plug it inside the y, what I will get?
You get -5.
-5, exactly. So y equal 2 times x. X is -1 minus 3. So the answer is -5 minus 5. Why? Because 2 times -1 is -2 minus 3 is -5. For the second point, 0, what I will get?
You get -3.
Plug the 0 inside this formula. So I get 2 times 0 is 0. Minus 3 is -3. So
I mean, if you think about it this way, right? If x-intercept is 0, then the y-intercept is the answer in this case, which is -3.
yes,
That's where
exactly. Yes, so this is the y-intercept. We will talk about this inside this section, in the end of this section. This is correct. And what about the 1 here?
You get -1.
2 times 1 is 2 minus 3. So it's -1. This is correct. So here, 2 minus 3 is -1. So the point here actually is -1 and -5. The point here is 0 and -3. Here the point is 1 and -1. For this point, y equal, when I plug the 2 inside this one, is 2 times 2, 4. 4 minus 1 is 1. So 2 and 1. For the third point is 3. 2 times 3 is 6. 6 minus 3 is, what is 6 minus 3? Is
6
3.
minus 3 is 3.
So here is 3. So the point actually is 3, 3. Now to graph this one, we have to graph the y and the x-axis. So the graph of the x-axis and the y is something like this. I'm going to write this one here. This is y equal 2x minus 3. Now at the point 0, we're starting point by point because it's called plotting point. At 0 is -3. So at 0 is -3. So this is 0 here. The x is 0. And the y is -3. So this is -1, -2, -3. This is the point, -3. So this is my first point is 0 and -3. Second point is 1 and -1. This is my 1 here. The x-axis, the x coordinate is 1, +1. And the y coordinate is -1. So again, this is my -1 here, -1, and this is 1. The point will be around here. The third point is 2 and 1. So this is my 1, this is my 2. And also the 1 will be like 2 and 1 here around, like around here, this point. This is 1. I'm sorry, this is 2, and this is 1. Now the third point is 3 and 3. So this is 2, 1, 2, and 3 here. And 3, 2 and 1, 3 and 3, 2, 3, 3 and 3. So the point will be like around here. So this is 3, this 3. And for the negative, at -1 is -1, so -5. So this is my -1, and -5 like goes down more and more, like around here. So if I get like, after I finish all the points, this point, this point, this point, I have to connect them. See the definition of the graph? We have to connect this point by smooth curve. So the smooth curve here is look like a line like this. Again, this is the line here. Something like this. This is the graph of this equation. Any question for how we can graph something like this? It makes sense how we can graph y equal to x minus 3. Okay, so now we're going to go over another example, y equal x squared plus 2. So the example 2, example here, example graph or sketch the equation y equal square root of x or x squared minus 2.
X square minus 2 or x minus 2?
It's x squared
Okay.
minus 2. So make it more better. Here, x squared minus 2. So y equal x squared minus 2. So to graph this one, we have to make a table again. So the table look like this. First one. Here's my table. So this is my x-axis here. And this is my y coordinate, and this is my x coordinate. So now I have again x, I have y that's equal x squared minus 2, and this is x comma y. And here I'm going to choose random points. For example, minus 3, minus 2, minus 1. Yeah, go ahead. 1.
Can you choose every other number? Then you have to
Yes,
do less.
you
You have to
can choose. Yes, you can choose any other numbers, whatever you like.
No,
But if you,
every other, so the graph is spread out in a short, or else
yeah,
it's going to.
you can take, like, for example, 0 and minus 1 and minus 2 instead of taking all these numbers. You can like taking just only 0, 1, 2, and here minus 1, minus 2. You're not sure to take a lot of points. You can take like 3 points, 4 points, or 5 points. For example, here, if I want to plug x equal minus 3 inside this one, what I'm going to get? When I plug the minus 3 inside this one,
7.
7. So because minus 3 squared, it's 9. 9 minus 2 is 7. So here y equal is minus 3 squared minus 2 is 7. So for the point minus 3 is they give me 7. This is the first coordinate order pair. So for minus 2, what I get?
2.
4. Yes, exactly. Minus 2 squared is 4. Minus 2. Minus 2 squared minus 2. So they give me 4. So minus 2, comma 4. Now for the third point, minus 1. What's the answer for minus 1?
-1.
Minus 1 square is 1. Minus 2 is minus 1. So minus 1 square minus 2, they give me minus 1. So the point here, minus 1, comma minus 1. For the 0,
It's -2.
is 0 square 0, minus 2 is minus 2. So for the 0 is minus 2. Now for the 1, 1
It's
square is 1.
-1.
Negative 1. Y equal negative 1. Why? Because the 1 square is 1. Minus 2 is negative 1. So the point here, 1, the order There is 1 and -1. For the 2, what's the value?
0.
For the -2, it should be -2 and 2, not 4, right?
Where, in which one?
The
Which point?
-2, the second one.
Oh, -2. So if I plug the -2 inside this one, so I get -2 square is 4.
Yeah,
4
and then
minus
you have
2.
to subtract, and it's going to be like 2, right? -2 and 2.
This is correct.
Okay, thank you.
Thanks. So here is the 2. This point is 2. Comma -2 and 2. For this point is 2 again. So the answer is 2 comma 2. And for the 3 is 3 squared is 9 minus 2 is 7. So y equal 7. For this point is 3 comma 7. Any question? Is not -2 and 2 for the second one? Yes, Eric, this is correct. Someone asked for the attendance link. Thanks, Victoria. Now, yes, go ahead.
For the attendance, is it the same link?
Yes, it's the same, right? Let me make sure. Here is the link. Again, this is the link here. Okay, now to graph this equation, we have to draw the x-axis, the Cartesian plane. This is my Cartesian plane, the x-axis and the y-axis. So something like this. Now, for the first point is 0 and -2. So 0 and -2 will be like around here. This is 0, and this is my -2, -1 and -2. This is the first point, 0 and -2. So here is -2. For the second point is 1 and -1. So this is 1 and the -1 like around here. This one, -1. For the second point is 2 and 2. So this is 2. And also this and the above is 2. 1, 2. This is the line. Here's the point in the middle. -2 and 2. And the other point, -2 and 2. I have also 3 and 7. So this is my 3. And 7 is in the above. Okay. So I have 3 here, 4, 5, 6, and 7. Here is the line, the y, and this is the x. So the graph will be around here. And for the y-axis, it's like here. Now for the other side, the negative, we have -1 and -1. So the -1 will be around here. And the -1 for the y-axis is here. So the graph actually will be like here. This is the -1, and this is the -1. So here -1, and this is -1. So the point will be like around here. Also, we have negative 2 and 2. So this is negative 2. I have negative 2 and also negative 2 for the x-axis. This is the negative 2 and the 2 is in the above here. So this point here is around here, negative 2. So this is negative 2. So the point will be like around here. This is negative 2 and 2. The third point is negative 3 and 7. So here's the negative 7. It's in the above. I mean, positive 7 and negative 3 like around here. So this is here is negative 3. So this is negative 3 and also this the point is 7. So the point like around here. So if I wanna graph or connect this point after I draw all this point, the graph will be like around something like this. You will see something like parabola. This is okay, like this side and the other side like this. Okay, it's a parabola. Any question for this one? Does it make sense how we can graph? Any question for this example? Again, this is my x-axis here. This is my x-axis, and this is the y-axis. 3, 4, 5, 6. Here I have 1, 2, 3. Okay, it makes sense how we can graph. Another example. We have another example. The example is graph y equal the absolute value of x. So to graph something like this, we have to again use the table. So the table, something like this here again. This is the table. So I have again my x value. This is my y value. Is the x coordinate. This is the Cartesian order pair x, y. So I'm going to choose random point is -2, -1, 0, 1, 2, and 3. Now, what's the absolute value for for the 0? For the first point?
2.
For the -2 is 2. This is correct because the absolute value, they change the negative to the positive. So the absolute value for -2 is 2. What about the -1?
It's 1.
Is 1. What about the 0?
0.
0. The 1?
1.
And the 2?
2.
And the last one, y equal 3. For x equal 3 is 3. So the absolute value for 3 is 3. So here the order pair is -2, comma 2. Here is -1 and 1. Here is 0 and 0. And this is 1 and 1. And 2 and 2. And the last one is 3 and 3.
It creates like a V shape.
Yes, will
Because they're
be
opposite.
exactly look like the V shape. So again, this is look like the V. So shape. So here I'm going to graph. I will graph the Cartesian plane. So if I have Cartesian plane like this, so again at the 0, the point look like 0. So here 0 and 0. So this is 0 and 0. Now down is 1 and 1. So this is 1 and this is 1. So the point like around here. Same things at 2 is 2 and 2. So if I'm looking for this graph, so the graph would be something like this. So this is the graph of this function, like the phi shape. How I know this one? By plotting the points from the question. 0, 0, 0, 0, 1 and 1. This is 1. 1 and 1. And 2 and 2. This is the 2 and 2 here around here. This is 2. And this here is 2. The lowest one is 3 and 3. So 3 and 3 like around here. Again, this is 3 and this 3. Same things for the negative. Point similar to this one in the negative. So the first point will be like around here. Second point will be around here. Third point is here. So again, the point here is -1, -2. The negative should be in front. -1, -2, and this is -3. This is the graph of the absolute value. Any question for this example? Makes sense? Now, we're going over the intercept. I'm going to give you the definition for the intercept, then we're going to finish this for today. So the intercept, we have two kinds of intercept. We have two different kinds of intercept. Intercept. So we have the X-intercept and the Y-intercept. We have the X-intercept and we have the second one is the Y-intercept. So the X-intercept, X-intercept, and also we have the Y-intercept. Here we have the X. So the X-intercept, first of all, it has definition. What's the meaning of X-intercept? Any idea? Any idea of the X-intercept? Okay, I'm going to give the definition is the X coordinate of points where the graph of equation intersect the x-axis. Intersect the x-axis. This is the definition. Now the question, how we can find this intercept? How to find the x-intercept? To find this, we have to set y equal 0 and solve for x. And for the second one, the y-intercept, same idea exactly, but instead of x, we have to change it to the y coordinate of points where the graph of equation intersect the y-axis. How to find the x-intercept? Just set x equals 0 and solve for y. Next time, we're going to give more details about this. We're going to stop up to here for today. Any question? Any question? Okay, I'll see you next week. Have a good day.